a look at section 9.10. All right, just before the break, I mentioned that section 9.10 deals with a way to make new carbon-carbon bonds. Very important in organic chemistry, making carbon-carbon bonds. And the way that we're going to do that is we're going to take advantage of the fact that we can deprotonate a terminal alkyne to make an alkynide. And we could also deprotonate acetylene. So I'll just write acetylene here. We could do the same thing, and we could end up with an acetylide. So let me just remind you of that. So this is an acetylide. And either way, we've got a negative charge on a carbon. And whether you have an acetylide, or an alkynide, those are good nucleophiles. So what does that mean? If they're good nucleophiles, if we react them with a methyl or a primary alkyl halide, we can do an SN2 like this, nucleophilic attack, followed by loss of leaving group, and we make a new carbon-carbon bond. Wow. Okay, so that helps us make bigger molecules. Alkylation of the alkynide or the acetylide is an SN2. So like I said, it works really well with methyl and primary alkyl halides. Doesn't work as well with secondary and tertiary because in those cases, elimination is going to predominate. We saw that way back in chapter 7. Take a look at this strategy here. Here we have one pentyne. It's a terminal alkyne. We treat that with sodium amide. What we get after that first step is going to be the alkynide. We're going to end up with this compound. And then that alkynide is going to do an SN2 on iodoethane to make this new carbon-carbon bond. There we go. So now we've made 3-heptyne. If you have acetylene, like I said, acetylene can undergo a deprotonation. You can actually deprotonate it twice. Why? Because you've got 2 acidic protons in the molecule. So we do our initial deprotonation followed by an SN2. We add the first alkyl group. Then we still have a second proton that can be abstracted with sodium amide. We do a second SN2, and now you've added not 1, but 2 alkyl groups, and now you've made an internal alkyne. Something that I want to point out with this strategy is when you're forming 2 carbon-carbon bonds, the order of the alkylations is not important. Order, put here, order, not important. Important. And I don't mean you can put an RX before NH2. What I mean is it wouldn't matter if you put this or this in first. Either way, if they're 2 different alkyl groups, you can put them in whatever order you want. Let's take a look here. Note that the double alkylation of acetylene has to be stepwise, so you have to do it one step after another after another. But like I was saying, you could add the methyl iodide first, and then you could add the ethyl iodide second. Either way, you're going to get the same product. Okay, it doesn't matter. And complex target molecules can be made by building a carbon skeleton and converting functional groups. So now we're on our way to making more complex molecules by creating new carbon-carbon bonds. Very, very important in organic chemistry.
I did have a question.
Yeah.
On this part here, when you say we can do a 2-step like this, that's under the assumption that it's a 1-to-1 like mole ratio. Like if we have excess of that ethyl iodine, we would do it to both sides if we had excess.
Yeah, exactly. So what you would do is you would treat, if you have 1 mole of this, you would use 1 mole here and 1 mole here. Absolutely. Yeah, if you treated it with excess and then you had excess ethyl iodide, then you just put an ethyl on both sides. Does that help? Or does that?
Yeah, that answered the question. I thought so. I just want to make sure.
Yeah. No, that's a great question. Equivalents are very important in organic chemistry, aren't they? Right. So that's why I drone on Clinton about things like, oh, this is excess. This is 1 equivalent. And the book is very good at trying to keep track of those kinds of things. So that's an excellent, excellent question. Well, with all that information in mind, let's see if we could build an alkyne and build make a carbon-carbon bond. So it says starting with nothing but acetylene, pretty cheap starting material. Just starting with that, let's see if we can make 1-butyne. So if we want to take acetylene and we want to make 1-butyne, so all we need to do is add an ethyl group to it. The first step is going to be treating it with sodium amide. Oops, sodium amide, like that, to make the acetylide. And then in the second step, since I'm only adding 2 carbons, I'm only adding just this ethyl group here. What do I need? I need just an ethyl group, and you can put a chlorine there, you can put a bromine there, you can put an iodine there. Either way, they're all gonna work. They will all work in an SN2 fashion, and you get the desired product. The next one we want to add, so this is called a benzyl group over here. This is called benzyl. And then over here we have an ethyl. Now, like I told you, the order is not important. We could add the benzyl group first to our, sp hybridized carbon, or we could add the ethyl group. It doesn't matter. Let's do it in alphabetical order. B comes before E. So let's see here. What are we going to do? We're going to take acetylene. Let's write the whole thing out. We're going to treat it with sodium amide in the first step. That's going to give us acetylide. You can put in the counterion if you want. You don't have to. Then we're going to treat it with benzyl bromide. I'm just going to replace the aromatic ring with pH. It means the same thing. So now we've got our triple bond, and we've got the benzyl group installed. Now we're going to do it again. We're going to treat it with sodium amide again. That gives us the alkynide, like this. You can put the sodium if you want. You don't have to put it in a spectator ion if you don't want. And then in the last step, we use iodoethane. And there we go. We end up with an ethyl group on this side, and we end up with our benzyl group on the other side. And that's it, my friends. And again, the order of addition, this and this, you could switch those. Okay, it wouldn't matter. And that's not supposed to be a resonance error. That just means you can put them in either order, and you're going to end up with the same product. Give me a thumbs up if you follow me on that. If you're like, Mr. Dion, I'm tired of organic chemistry today, but I understand what's going on. All right, great. I wouldn't blame you for being tired one bit. So that covers all of chapter 9, except for the last section, which is nothing more than just kind of putting everything that we've learned together and just saying, okay, well, these are all the different conditions for reductions that we've learned: reduction of alkenes and alkynes, reduction of an alkyne to a transalkene to a cisalkene. Then we talked about halogenation and double elimination to make a triple bond. We went over that in detail. And really everything here, except for this one reaction, how to go from an alkane to an alkene, we've covered all of these. Students will sometimes ask me, is there a summary of everything? Yeah, well, here's a summary of all the reactions that we looked at. Mechanisms that you want to know. I'll put the letter M. You're going to want to know the mechanism of elimination. Hydrohalogenation, 2 equivalents. I'm probably not going to ask you about that one. 1 equivalent, again, I probably won't ask you that one either. Acid catalyzed hydration, no. Hydroboration oxidation, no. Halogenation, no. Halogenation, 2 equivalents. What didn't it say? It wasn't even all that well known. Ozonolysis, no. Alkylation, no. Dissolving metal reduction. This is covered in chapter 10, so we'll worry about that later. Hydrogenation, you have to have an idea about syn addition. So I'd say besides the double elimination, you'd want to know about the alkylation mechanism for sure. And then for the acid catalyzed hydration and hydroboration oxidation, you want to know the mechanism of tautomerization. So tautomerization in acid or base. You want to know both of those. All right. And then we have the whole summary right here. So we've covered everything. And what we're going to do first thing on Monday morning is we're going to take a look at question 9.29. So be sure to try. I have 6 problems here. Be sure to give all of these a try, and then we're going to come back and we're going to take a hard look at all these. And then once we finish those, depending on time, we might do a couple more problems, or we will just, but either way, we're going to start chapter 10 on Monday, which deals with radical chemistry. So there you go. We've covered a lot of alkyne work today. And